In the history of case study being asked in class 12 CBSE board exam, this was the first ever time that a question came from this chapter, applications of integration. Thankfully, it was not a very difficult question. Many people were able to solve it without much fuss. All right, we'll take a look at the question. Roundabouts are often made on busy roads to ease the traffic and avoid red lights. One such roundabout is made such that the equation representing its boundary is given by C1 is equal to, there is a curve given. If you look at the curve, it is a circle because the coefficient of x square and the coefficient of y square is both equal and it's equal to 1. Likewise, there is a circular pond with a fountain in the middle of the roundabout whose equation is given by x square plus y square is equal to 4. This is also a circular equation whose coefficients of x square and y square, they are both equal and they're equal to 1. Now, if you recall the equation of the circle, so that would be x square plus y square, that is equal to a square or r square, whose center is origin 0 comma 0, correct? And the radius is equal to r. So if we compare the given two equations, x square plus y square is equal to 64. The center does not change, but the radius in this case would be 8. And the second circle's radius would be 2, correct? Now, we'll try to answer the questions. Represent the given equations C1 and C2 with the help of a diagram. Remember, in the middle of the roundabout, there is a circular pond. So it should look like concentric circles. Now, I'm drawing a circle here. Inside this, there is one more circle. Right? Now I'm drawing x-axis and y-axis. Should have been much more central, right? So I'll try to, and the one which is inside should have been more centric. Okay, so this one is x square plus y square, that is equal to 64, and this one is x square plus y square is equal to 4, and the bigger radius would be 8 and the smaller radius would be 2. Represent the given equations. So just draw one circle inside another circle representing two concentric circles with same center. Make sure the center lies at origin 0 comma 0 and just name the two circles. That's it. Express y as a function of x, like y is equal to f of x for C1 as well as C2. This is the answer for the first question. For the second question, we need to rewrite y is equal to in terms of x. So y square is equal to, so I'm writing curve 1, y square is equal to 64 minus x square. So y would be equal to square root of 64 minus x square. That's it. For curve 2, y square is equal to 4 minus x square. So y is equal to square root of 4 minus x square. That's it. Now, using integration, find the area of the region covered by roundabout. Now, the roundabout is the whole of the circular region, right? It also includes the circular pond. They're not excluding, they're not asking us to exclude the circular pond. So we need to find the area of the roundabout, the whole of it, without excluding any circular pond or any area for that matter. So 3a, the area is given by integration of y dx, because we have the y in terms of x ready. And remember, we are only finding the quadrant 1 area, and after finding that I'm going to multiply it with 4. So this is only the quadrant 1's area. So that would be from 0 to 8. So integration 0 to 8, in place of y, we'll write this as root of 64 minus x square. To be doubly sure, what we'll do is use the rough column to find the area of the circle whose radius is 8. So pi r square is the area, and area would be equal to 64 pi, that is for the whole circle. Now the Q1's area, just the quadrant 1's area, should have been 16 pi, correct? So integration 0 to 8. Now if we integrate this is of the form integration of root of a square minus x square. So that would be x by 2 square root of a square minus x square plus a square by 2 sine inverse of x divided by a. So this would be x by 2 root of 64 minus x square plus a square is what? 64. So 64 by 2 is 32 sine inverse of x by a. A is 8. X by 8. The limits are from 0 to 8. So that would be equal to 8 by 2 is what? 4. And this gets nullified. This becomes 0 plus 32 times of sine inverse of 1 minus. So this becomes 0 and this also becomes 0. So that would be equal to 4 times 0 is 0, right? So 32 into sine inverse of 1. So that would be pi by 2. So we have the answer, which is 16 pi. So our answer is also correct from what we did earlier in the rough column. So this is, remember, this is only the quadrant 1's area. So we need the full circle. The quadrants are all identical. All 4 quadrants are identical. The full circle's area would be 16 pi times 4, which is equal to 64 pi. On to the next question. Using integration, find the area of the region covered by the circular pond. Similar method to be followed. So 3b area of just quadrant 1, that is equal to, you may have to redraw the circles individually here. I'm not drawing it because I've already drawn it once for the first subdivision. While writing in the exam, you might have to draw the diagram, at least a rough version of it, whenever you're finding the area using integration. Okay. So 3b, that would be from 0 to 2, because the radius is what? 2. And y dx, so that is equal to integration 0 to 2. Here that would be root over 4 minus x square dx. So that is equal to x by 2 square root of 4 minus x square plus a square by 2, which is 2 into sine inverse of x by a. X by 2, the limits are from 0 to 2. So that is equal to 2 by 2 is what? 1. But 1 into root over 4 minus 4, which is 0, plus 2 times of sine inverse of 1 minus the lower limit. This is 0. This part becomes 0 when you apply the lower limit, and the other part also becomes 0. So that would be, this whole part is gone. This part would lead to 2 times of pi by 2, which is equal to pi. Remember, this is only the quadrant 1's area. So the whole circle area would be equal to 4 times of quadrant 1, which is 4 times of pi. So we'll just quickly cross check if this is the actual area. Radius is what? 2. So pi r square, which is equal to pi times of 2 square, which is 4 pi. So our answer is also correct. So that brings us to the end of this question. If you have any other queries or if you have any other questions to discuss, let me know in the comment section.